Okay, you have picked all of your points, you have a reference image, and you have your alignments done, which you should already know how to do. So you're ready to actually start your data collection. So the first thing you want to do is make sure that your data is going into the correct directory. So we're going to go to Setup, Set File Options, and you're going to be greeted with a window that looks like this. You're going to leave everything as the default settings, except you're going to change the base name in this window. So we're going to give it the correct date, and then the protein name. This is A9. Okay, and we want to set the folder that the data is going to be saved in. So I'm in my original directory that I've saved my atlas and everything in, and then I've made a new folder called stack, and I want to select that folder, and my data will be saved there. Okay, we're good. And last but not least, this is something you're going to forget a few times once you start doing this without any helpful videos, is loading a image into BufferP. So you're going to close out the current window, and you're going to read the image that you have saved. So I usually go back to the original reference image I have, which is going to be in your working directory. So right now we're working under Stanley, and then MUA, and then we saved it as P, and that will load that whole. Okay, and with all of that done, you have one more thing to check, and that is the script that you'll be working with. And we usually use a script called SPAC2Fast, which in our case is number 2. And we want to look at the defocus range that we've set. I actually don't want to use 2. I want to use something more along the lines of 1.5. Okay, because I already know what these particles look like and they give good contrast. And then our drift interval is sometimes subject to change, and we want to verify that it is 0.5 as it is usually. If we increase the magnification or want to just collect a quick data set, sometimes we'll reduce that or raise it to 1 or 0.75. But for now it's good. This is what we use for standard settings, and we will say OK. So now we want to go through and double check everything. We have our reference hole loaded. We have our alignments done. We have our 50 C2 aperture and our 100 objective aperture in. And we have done our beam alignments. So now we are ready to actually start collecting data. So to do that, we will go to Navigator, Acquired Items, and we will turn off Rough and Fine Eccentricity, and we will run our script, which is called SPAC2Fast, and we will tell it to close our column valves when the program is done running. So we'll say go, and what we'll see is our stage will move to the very first hole, and it will do a comparison and align to that hole, and you want to verify that that alignment is correct. If what you see is a misalignment where the red cross is in the corner or even off of the hole, you need to load a new buffer image. Okay, and it looks like it's going to run correctly. And it found the center, so it looks like we are good, and now it's going to move to the area we have determined as a focus area. And if you follow your log window here on the side, you can see that it's now starting to autofocus. And at the very beginning, you have to wait for the drift to die down, and sometimes that can take a minute. So now it's running drift, and it will give you a readout, and it will begin collection as soon as it gets below the threshold that we've set, which was 0.5 angstroms per second, or 0.5 nanometers per second, my mistake. Okay, so that is how you start data collection, and you should monitor this for a few minutes after you have actually seen images being collected. Verify that your holes are good quality and that the data output is great. And then you can move on to automated pre-processing in Scipyon.